All right, so I've divided into 2 clusters. Dr. Amin, we now have 2 clusters. All right, ladies and gentlemen, I hope breakfast, coffee and tea break was good. We enjoyed it, right? Now we continue quickly. May I now invite Engineer Dr. Patrick Amor-Beke to please come forward as he now takes the next training. No, you should. As he takes the next training item, which is Introduction to MEPDG and its role in enhancement of roads sustainability. By the time he comes, we would know what MEPDG is. Thank you. So let's have Doctor take us. We'll take it. Please, a round of applause for him. Put your hands together for him. Thank you. So, yeah.
Thank you very much, and good morning once again. All right, are we ready? Good. So I'm going to talk about MEPDG. I'm sure before we go to the slide mode, who has heard about it before? Mechanistic and empirical pavement design guide. Okay, let me ask the question. What design method is popular? Do you use, let me start with Nigeria before I come to Ghana. Anyone? Empirical, ASHTO, 93. What design, basically pavement design guide do you use? Not mixture, but thickness design. Do you use? ASHTO 93. What again? So road nodes 31, very good. So you use road nodes 31, ASHTO 93, what again? So you can go to the slide mode. So when you were in school and you were doing pavement design, maybe we'll come back to that. Let's go directly to the slides. So what I'm going to look at is basically talk about the components of pavement engineering, give some definitions, PMS, the principles, some of the things that Prof just talked about. Just re-emphasize it and how it's linked to what we are going to do. Pavement evaluation, I'll talk a little about it. And then economic analysis. Tomorrow we'll dwell more on economic life cycle cost analysis and database and how to do MEPDG. Please, you are giving me the wrong slide. Number 2, this is not a slide. MEP, Yes, they've switched it. That's okay. So, are you ready? Or let me still continue. Yes. Not this one. Pavement, mechanistic and empirical pavement design. Mechanistic and empirical pavement design. That is the slide. While he's looking for that, so let's look at traditional pavement design. He talked about Road Note 31. Road Note 31 is mainly a catalog-based design. If you recall, under Road Note 31, what do we do? Basically, you assess your subgrade. The key to is your assessment of subgrade, and then if you're able to adjust for moisture and everything, then you assess your traffic, okay? And then a basic design, you go to your catalog, your subgrade class, your traffic class, and it will tell you that this is your pavement structure. That's what you typically do. Actually, if you are also dealing with ASHTO, now let's look at how ASHTO was developed. ASHTO, who knows the history about the ASHTO, the history of ASHTO development? They basically did some test track, okay? And I'll talk about that. They did some test track. Well, they were able to understand, based on that experiment, how pavement feel, and they came out with some design guidelines, okay? And so in ASHTO, what do you do? It's the same traffic. If you remember your ASHTO pavement design, the key things that you need, your subgrade properties, and then you move it from there. Okay, they said we are ready. Now, so that's the process that you go through. In both processes, what we don't know is after you are done, you are not able to know how your pavement will perform in future. You cannot tell from today that, well, in 10 years' time, all things being equal, this is the number of cracks that I'll have. Am I right? Or this is the depth of routing that we'll have. The other aspect of it is that, and I'm saying that when you were in school, you learned about some mechanics. Remember, you load stresses, stress distribution, and then you determine, I met a PhD student right now, you determine the stresses and the strain. And so for routing, you are dealing with what? Strain. You want to look at the strain and the right. Now, those are mechanistic. So when we say something is mechanistic, what comes into your mind? You are dealing with those loads, the mechanical properties, basically dealing with the basics of our designs. Let me put it that way. Then when we say something is empirical, what comes into your mind? Experience. So based on experience, try and error, what we've seen. So ASHTO is mainly based on experience. Am I right? They did some test track, but they did it for a limited distance. Now, what later on we are going to see under the MEPDG is they try to marry both using what I started with again, data. Using what? Data. All right, so let's follow the slide so that I do not digress. So I talked about ASHTO. This basically gives you the development of ASHTO, and there has been so many modification since then. But what happened under ASHTO? Well, you will notice that they did it at a particular place. Am I right? Now, we are aware that climate affects our pavements. So the behavior of a particular pavement in Kaduna will be different from Lagos. All things being equal. Even with the same traffic, everything, there will be differences. And just because of the effect of the location, that's the climate. Subgrade, I don't need to talk about it, certainly also affect it. The surface material, if you look at the ASHTO, they looked at two main types of pavement materials, mainly HMA and PCC. Those who have used ASHTO before. Base course, they also looked at two main materials, the unbound and the dense granular base. Then they did not look at rehabilitation techniques. So that's the restriction, but that's the pavement design that we've been using 93. Of course, there's been some improvement over the period. Now, sorry. The other thing, so these are the deficiencies with the old ASHTO, and it applies to the Road Note 31 that our elder just talked about. Traffic laws have changed significantly over the period. We were talking about even different tire configuration. I was having a discussion with Doctor not long ago. Tires have changed, and Doc, Prof, you know, I don't know whether we talked about top-down cracking, and one of the things is the even effect of tires. I mean, there have been research in that area. There are now different tire types, tire configuration, and it's affecting our pavement differently. So all those things have now. Vehicles characteristics, as I said, has changed. Materials have also changed over the period. The kind of materials that were, and drainage provisions have been also updated. So, well, why do we need a new approach? Well, I've defined it, but it says that mechanistic empirical pavement design guide, it's a combination of the mechanistic, okay, understanding the mechanism, let me put it that way, and then the experience, combining them together. Well, and I did some work with the French company, and they rely so much. If you've seen any of France or any of the French-speaking countries, they like the mechanistic approach. So they will still go through, calculate strains, the allowable strain, and that's what they use. They don't also believe in the empirical approach. So you will have different distance, but this method tries to marry both, whether it's mechanistic or empirical. And we'll look at the advantages and disadvantages of both, whether you are dealing with mechanistic or empirical. Now, let's now look at the advantages of MEPG if we are to marry. Now, let me jump this. I'll come back to it before we look at the advantages. 1 minute. I'll come back to the advantages and disadvantages. Okay. So, what are we trying to achieve with this method? I just want for you to understand this whole method. we know mechanics of material. We know that, I want to draw that, if we apply load is distributed within our pavement, and we can calculate what stresses and at least stresses and strain deformation from it. We know that, so that can give us an idea of the behavior, okay? We know from either soil mechanics, at least even if you don't know anything from Buzinics, you can calculate this. Then you went to Bemister, you remember you did multi-layer analysis from it. So we have that idea. We can get some strength. If you know the material properties, we can know what stress is going on each layer. That is clear. But we can use different methods to calculate stresses, strain, deflection mechanistically. But that does not tell us performance, long-term performance. That's what we are lacking. Am I right? That's what we are lacking. But we also know that from experience, if yesterday the premise with which, and today what we've just done, from the AI with all the data, that we can have an idea that for a pavement that was constructed this way, okay? So we are thinking about ASHTO, but ASHTO in Nigeria, with these properties, when with this traffic, with this weather condition, with all this, when after 10 years, the percentage of alligator cracking was what? 10%. We can learn. And let me use Engineer Felix and co. The older people can tell you that, oh, this road, we constructed it this year. If they have information, they can tell you, this contractor constructed it, this is where we got the aggregate. No, they can give you a lot of history about it. So we can use data now to go to the next stage, which is what we call the empirical aspect. That's based on experience, tell you. Now, what MEPDG talks about is to marry both. That's the long and short of all that. To marry both and tell you that, okay, we will pick all the factors for design, do a mechanistic prediction, however, also use the experience that we've learned in the past to predict the future performance. And that is when data, AI, and all those things then comes into play. And the US have spent a lot of time to collect all this data, and now they can use that to say that for this road, and that's the long end story, with this material properties, with this, if we do all the evaluation, one, we are able to now do a design. And this design is able to tell you, okay, in 10 years, we'll have this percentage of crack, this ratting, this is the material mixed properties that you should. So it will give you everything. Remember, in your typical mechanistic design, it will give you only thickness of pavement, am I right? And give you elastic modulus, am I right? In road note 31, it will give you also thicknesses, and that's all. And you now have to now go back and do this system will now even give you the mixed properties. So yesterday, the things that we talked about, it can predict, and you can now look at when you need to, so we'll talk about decision constructability issues, or life cycle costs, how long it will go, when you are supposed to do rehabilitation, all those things can be predicted under this system. So that's what we are going to look at. But so before we do that, I just want to talk about the advantages and, of course, disadvantages. So So reduce early failure, reduce early failure, so you are able to better incorporate material properties and all those things into it. Increase the surface life, mainly you have a better understanding. So your life cycle cost, we'll talk about that tomorrow, is basically improved. The other thing is that new loadings are now incorporated. So we'll look at that when we go through. So current loading systems, we now understand loads. They are all premature distress evaluation are also included. Drainage impacts is seriously included. Road Note 31 and even ASHTO and some of the other design, we have only some drainage parameters, M1, M2, if you recall. This one, the actual site-specific load data and drainage data can be included. Aging of asphalt, we learned about the effect of aging is also included, and flexible with site condition, environmental, and load. So that's one of the advantages. Now, the disadvantages is that it's a huge software. The software is huge. When I was doing my PhD, it used to be free for students, but it's huge. You need a lot of training to be able to use it. But now it's cost so high and quite complex. It requires a lot of data, and it requires a lot of discipline to use it. So some people use it and they don't have the data and they keep on assuming. And as Prof just said, garbage in, garbage out. So it's to use such a system, I'll always go back, understand the data requirements. Understand the data requirements and prepare yourself towards it. And I'll come back to it. Most of us, we rush to use systems without really thinking through what does the system require. Just this morning, yesterday in the evening, I had a call from Ghana. They want me to use HDM4 to do some exercise. And I asked, why HDM4? So, it's HDM4. I said, what are you doing? And basically, they are looking at a sealed road, chip seal road. The traffic is not so high. And I said, the data requirement for this particular road, you will not have it. I'll do it for you, I'll charge you. But it will not help you. We'll get some results, but the results will be wrong. Or it will not tell us anything. And the lady was like, no, doc. Then I said, okay, what about RED? And I think she didn't know much about RED, Road Economic Decision Model. Then I said, looking at the traffic volumes, let's use RED. I convinced her. And then this morning, before we had a chat about it, I think she's gone to read about the RED. And she now says, okay, if RED can give you the same results, then let's use RED. But the reason I'm saying is that, who has used HDM4 before?
I tried, but the data required is too much.
Yes, HDM4 is data hungry. You need a lot of data. And it needs institutional, let me use the word, leadership, so that you start collecting that data for the analysis. Even RED. So RED, if you are dealing with VOCs, who is collecting your data on to be able to properly calibrate your VOCs? Sometimes we forget about it, that, what is in the software, that simple equation, VOC is equal to IRI and all those things. But what are the vehicle fleets even within Nigeria, within Ghana, or within the locality, who is collecting those data to be able to predict a better VOC? I think we forget about that. So it's complex, it's a good system, and it's a better system, but we need to intentionally collect the right data to be able to use. That's what I will add. Now, so the other disadvantage is most of the calculations are done in the background. But actually, even it's a disadvantage, the notes gives you the calculations that they use. So, for example, in Ghana, some professors have worked on coming out with some transfer functions based on the temperature, and just for our locality, Dr. Tutu worked on something like that. So generally, there are 3 levels of data inputs, level 1, level 2, and level 3. So when we say level 1, we have what we call the site or material specific inputs. That is very detailed. So here at the design stage, you are picking this road, the aggregates, you know that site specific, where you are getting your aggregate from. Everything about your design is from it's based on what you are going to use. I don't know whether you get me. Then we have level 2, which is basically using previous data, okay, or data that has been established on the average within a particular climate. Then level 3 is more national or regional level. So if you are dealing with level 3, design is easy. You say, so you are saying that Nigeria, all the climates is the same. Traffic, you find some average and you use it. But the lower your level, the more accurate your analysis is. So these are the 3 levels. I've talked about this before. So basically, your level is like any pavement design. Your traffic characterization does not change, okay? Your foundation, your subgrade, your foundation parameters, whether there are issues with some, I mean, we don't deal with frost, but you have an expansive clay or something, those things are the same. Then the key thing that I want to emphasize is now they have climate data, climate specific data. When I returned from the US, I used Florida. You know, they store it at IC data, your climate specific data. And so based on the climate you use it. I know under the ECOWAS project, PEL, you know, PEL Consort from Nigeria, I know they tried to use MEPDG for some of the sections in the design. Then you also input the material properties and the granular material properties. So depending on the level you are dealing with, if it's level 1, then you have to do a lot of laboratory tests to confirm your material properties to be able to input into it. Then there is this black box with this input. And what does the black box do? The black box is able to now combine this, do a lot of analysis, and here is not only using mechanistic, it's also dealing with predictions, okay? Predictions that, okay, based on this experience, this is going to be the routing in 3 years' time. This is going to do the cracking. You remember in your normal distance, you don't get that effect, but the MEPDG is able to do this thing. Then you can now go in, okay, so basically pavement analysis is modified, distresses, it's able to predict distresses as I talked, damage factor accumulation, whether it meets your performance, then you keep on modifying your strategy. So, okay, based on this, I want to increase the thickness of the pavement or reduce it, maybe use a more dense material. So you are actually involved in the design processes within this blackboxing. And then if it meets your performance criteria, then you now look at the alternatives. So for example, alternatives. So if we are constructing within 3 years, in 10 years, are we sure that we can do maintenance? If we do preventive maintenance in 10 years, then you do this life cycle cost analysis. Remember, all these things that we've been talking about, that pavement deteriorates, the condition decreases, are all incorporated in this system. So you're able to think through, see it based on data, and say that, well, all things in, because, so for example, you know that the federal government roads, routine maintenance, they will always give you money for routine maintenance. But when it's maybe the 7th year to bring money for preventive maintenance, they don't give it. It comes on the 10th year. I'm just using that. Or it comes in the 10th year. You can simulate that in the system. I don't know whether you get me. Are you following? Okay, it comes in the 10th, so you simulate, and it's able to tell you your condition of your pavement from day 0. It's able to tell you 20 years. This pavement, based on your maintenance regime, this is what is going to happen. So you are simulating your specific strategy in terms of the pavement design. So this is the game changer in this thing. All the other pavement designs, you are not able to predict what will happen. So you can tell, even if there is budget constraint, you can use this and tell the politician that, well, this road that we are doing, if you don't give us money this time, or you are not consistent with your routine maintenance, this is what is going to happen. In 10 years' time, your cracks will move from 10% to maybe 25%. Potholes will increase this way. I don't know whether I'm making sense. And in that case, the public will not be happy. Because, sometimes the public thinks that engineers, we are the cause, we are not doing well. Oh, we've done this road. Within 5 years, the road is failing. But what we don't tell them that, yes, within that 5 years, we needed to do some simple routine maintenance. The failure to even desilt your culverts, and that will increase moisture damage and can affect your overall performance. That's a story we don't tell. So people think, oh, this road has lasted 30 years. It's lasted 30 years because they had what? Consistent and constant what? Maintenance. And we'll look at that. So basically, this is MEPDG. That's all it's about. The rest is just about going to the details. So I've already explained it, the analysis, and then the final selection. So this is the software. As I said, it's quite expensive. So you start by inputting whether you are dealing with level 1, level 2, or level 3. I've explained that. Or you are dealing with national distance. Unfortunately, all the data in the system now are for the US, and I'm sure maybe Canada. So if we want to do it in our place, we need to start once again dealing with data. Traffic they've collected, so the work that you are doing, it's a very good candidate for such a system. So as you collect the data over a long period of time, someone at the national level needs to aggregate all those roads, and that could be it. And so let me jump a step wise. So one of the things is we have good tools available. nowadays I tell my engineer that your phone, you know, now if I take a photo here, our phone is able to tell us the GPS locations, the picture, and the location. And that is perfect. So wherever we go and we are picking data, you just pick the GPS location. The moment it's georeference, one day you can use them. All you need is the georeference location. So that's also to you, it's something, Doc, you can look at that. Then they have the climate level data. As I said, you can have the site-specific one. So they have scattered meteo stations around, but for pavements, data collection, you know, yesterday I talked about even pavement temperature and all those things. They have all those data, but we can start from somewhere. We may not want to go there, but just having an idea of basic rainfall, sunshine, and those things can help from the beginning. And I believe we are doing it, but we've not been intentional at the national level. So that's also another input that you will listen. Then the materials. So I've explained that there are three. General default values recommended level 3, regional aggregated level 2, but you can do laboratory testing for each and every material. So for example, if you are dealing with your unbound material, you now have to then do your resilience modulus test and get all those parameters. So your asphalt, you do all those tests and get the parameters into the system. And you'll see an example very soon. Okay, so these are the materials. And as I said, remember in the ASHTO, we're dealing with mainly 2 main materials, HMA and PCC. Do you recall that? I said that earlier on. Now there are so many different material combinations, and you can have them, and even with this, you can enter the actual property, your mixed property that you are going to use for the level 1. If now we have chemical stabilized materials available, so all this can be inputted into the system. The unbound material, I talked about ASHTO, we had 2, am I right? Now you have all these combination, even some of the unbound soils have changed, we have recycled, and all those things can now be inputted into the material. So these are just snapshots from the software. So now you can go into rates, input the different category, the volumetric properties that we talked about yesterday, also into the system. So if you've done a mixed design, that can be for asphalt, you can input that into rate if you are dealing with level 1, or you pick the default values. Oh. Okay, so this is the point that I was trying to make. Then, in the same way, it's just those properties, Poisson ratio. These are recommended values. Let me pause a little and engage you. So, what is Poisson ratio? I am asking this is a question in my foundation class. This is not for the old people. In my foundation class at the university, I normally ask them to give me the typical Poisson ratio of soils. Of course, now you can easily Google and get it. And AI will tell you. But what is Poisson ratio? Anyone? From the back. Sometimes we get these things and it's abstract. What does it tell you? Oh. Prof just said you were very engaging, and now you don't want to be engaging to me. Yes. Okay. All right. Any other thoughts? Stress strain. Okay. Any other thoughts? Let's say it. One of my teachers says, say something, there's no police around to arrest you. Yes. Oh, I want one from the back, but they are getting people only from here. Yes. Okay, how material response? Oh, my friend at the back. Oh, you are dodging me now. Anyone, please. So, basically, yes, so everything you've said to an extent is true, but he gave the exact definition, the first speaker. So based on that, what do you expect the Poisson ratio of asphalt to be? Asphalt concrete mix. What will be the range? Please. Ima, notify me when I have 20 minutes. Oh, yes, madam. Just say something. Okay, go ahead. Yes, go ahead. I don't want to. Yeah, you are right, but yeah.
My last project will get within the range of 0.35, 3.36.
0.35, okay.
0.34.
Okay.
That range.
Very good. Okay. Any other? So he said that when you have any material, okay, we know strain. Strain is basically the change in length or the deformation over the original. And he said that when you have a material and you compress it this way, okay, there is a vertical strain. But you agree with me that here too, there is lateral strain. Okay. From his definition, which we all believe, he says Poisson ratio is basically the ratio between this one over this. Am I right? The lateral over what? Over the vertical. And so all things being equal, depending on the material, we expect this one to be larger. Am I right? This to be, and this one will be smaller. So a material that will have a small this way will have a smaller Poisson ratio. Am I right? That's what he's saying. A material that will have a big this way, when we press it, it will go this way, will have what? A higher what? Poisson. That's basically what he said. I didn't say it. And we believe him. All right. So I'm saying this because sometimes at the beginning you don't have these values, and you should know when you do your indirect tensile test and all those, and it will give you your Poisson ratio. But just don't enter values. You should understand the meaning of the values and what you are getting, whether it's normal, it's within range, what is happening. So if it was concrete, what do we expect? Concrete and asphalt, which one will have a higher Poisson ratio? Okay, now we understand. we already know it. I'm just reminding you. You did this in mechanics before, but I'm just trying to remind you on the practical implication of this. So depending on the kind of data, you can use the default values if you are dealing with level 3 or level 1 based on the test. Someone just said they did some tests and you got, so you can put that into it. Now let's move on. Just emphasizing what I just talked about in terms of Poisson ratio and getting your E, which is the resilient modulus. Okay, so these are properties that you need to input in, and how they are temperature dependent. Also, remember your Poisson ratio is also temperature dependent. I hope you agree with me. Okay, all right. Okay, so other properties, mechanical properties of your material that you put in your dynamic modulus, your asphalt binder, and normally you get your indirect tensile test and your creep properties. Or your creep compliance. I believe we all know what creep is. Okay, all right. And when you do the IDT, you get your creep compliance also from your test. Now, dynamic modulus, I remember when I was talking yesterday, I was talking about DSR. You remember that? You're able to, for your binder, here I'm talking about your binder, but you are able to also determine your dynamic modulus for your asphalt. Okay, so you can, depending on the level 1, level 2, level 3, and these are all material properties. I'll be quick over here. And remember, for your asphalt is a viscoelastic material, so your climatic effects, the temperature affects those properties, and those are the things that you input in. In the same way, you also input your aggregates, whether a site-specific properties into the system, and it will use that to do your analysis for you. So the type of aggregate you are using for the various layers will also, the binder, I'll be a little quick from here. Then I've talked about your thermal properties already. Aggregate coefficient of thermal expansion of your aggregates, CTE. I think those in the lab, you do CTE. Where's my friend? Today he's changed his position. Where is he? Okay. No, yesterday I was identifying him with you. All right. So thermal inputs, let me go ahead. So these are your unbound material. I've talked about them already. Normally, they tend to be your base and your sub-base materials, and their properties. You also give those same inputs into them. So these are various material strategies, but you have not done a design yet. These are inputs. The design, after all this input, then it will do the analysis for you and come out with possible designs. And then you yourself will now go in and say, no, these are my criteria. I want, that's what I was showing you, that there's a big black box over there that you need to look at. So let's go ahead. Okay. All right, so these are how you do determine the unbound material. So these are various inputs, your densities, and all those things. So now, after all this analysis, as I said, there is this big black box, and then it will come out with viable alternatives that you can do. So your mechanistic, it will do those stress strain deflection analysis. It will use previous observation and give you some recommendations. So now, unlike our previous design methods, the recommendations are not just only layer thickness. I'm emphasizing again. They are not only layer thickness, okay? You go beyond layer thickness to now mix constituents. I hope you get me. Then subgrade recommendation, okay? What should you do to your subgrade? Do you understand whether it needs any improvement? And then the drainage requirements. So this is the difference. That's the first one. So you can actually Google ASHOWELL, the software, and you can have a feel of it. Now, so these are just inputs that explaining the various things that I've talked about, and then you now deal with issues about constructability. So here we are now dealing with constructability, life cycle analysis. No, I explained that earlier on. You are dealing with in 5 years what will happen, and you can actually see what will be your percentage of cracks, what will be your rats death. All those things will be predicted, and your strategy that you can do, and that's now the difference within the difference that we have. All right, so from here it's academic, so I'm going to be quick. So the stresses, we know stresses, we've talked about this, the mechanistic aspects that we talked about, I'm just repeating. So these are stresses, there are different stresses in your pavement, and this is how the system is able to calculate all those things. So for our purpose, this is a typical pavement. So we are dealing with 6 shear stresses. We have your axial and all those stresses, as we know from mechanics. And your strains, it's able to model all your strains. So I'll come to you. So remember this, those who have done Maxwell viscoelastic models, those doing your PhDs in material, you should know this, but spring and a dashboard, and you can have the Kelvin, different methods, but this is just this thing, and it's able to use that to predict. So if you give those granular data, that's what it's using to do the analysis for you. So that's the mechanistic aspect, and it's then able to predict racks, which is a function of the binder and all those things that we've talked about, the distresses. Yesterday I talked about some of these things, mixed ratting, subgrade ratting, then basically there are 2 main, where the wheel is consolidating or the base itself is failing here, or there's instability within the surface. Within the surface. So yes. Yeah. Yes.
For those who are into design.
Yes.
In the last 4 years,
yeah,
I've been to so many projects.
Yeah.
And I discovered that the pavement design fails as a result of the fact that they assume uniform CBR.
Okay.
Take ABUJA to Kano, for instance.
Yeah.
When the CBR was conducted initially,
yeah,
some areas were above 10, some above 15. But in design, they assume a particular value. And this has resulted as a result of failure. You see, unsuitables, sometimes within the range of 300 meters, 200 meters, you will notice a failure on unsuitable material. So since we are considering having this kind of ME design, what do you want us, the designers, to be a kind of a consideration when they are using their CBR value for a long stretch of roads? Maybe for instance, from ABUJA to Lokoja. We talked about at the early part of this lecture on Monday why we have those failures along ABUJA, maybe as a result of poor compression, but I feel the failure started from the CBR value they use in design. So please, you can advise us.
All right. So let me say that in all these things, the basic principles of design do not go away. So when you do your subgrade investigation, and he's saying CBR, I use the word resilient modulus or whatever. Now, what do you typically do? When you come back, you now do your sections. Do you understand? That does not go away in this system. So you typically will deal with your prediction and say that, to make it simple, from here to here, the CBR is 15. Your subgrade CBR is 15. From here to here is 5, and we need some major improvement, stabilization. That does not go away. From here to here, you have a CBR of maybe 30, okay? And you think, based on your standards and all those things, it's okay, it meets it. So the sectioning is still done, irrespective of the method that you are using. What this now says that, assuming we are dealing with level 1, when we came here, we input all the parameters that we got here into the system, and it's able to tell us that from chainage 7 plus 00 to chainage this 12 plus 00, this 5 kilometer section, this should be the design. And remember, I talked about constructability. Every time you are doing design, when you are done, step back. And I always say that, step back and think about how it's going to be constructed, so that it's not every 500 meters, then you change pavement types. That one, no contractor will agree to do it. So a good designer is a designer who understands construction and what happens in the field, whether it's in the building, whatever, roads, whatever. You should always step back and think about construction. So I agree with you. Some people go to the codes and say that because the code says use a CBR of 15, then they assume a CBR of 15 throughout. That is also not acceptable. So those principles remain the same. Okay. All right. So let me. I think I have some few more minutes. Yes. No, can we have the microphone so that?
So earlier you mentioned marrying the two, the mechanistic, empirical, and the empirical. You talked about also factoring the projection into the future. And then another factor that came in was the economic bit of it.
Yes.
The availability of funds and all of that.
Yes.
Now, in a situation where you have instability, for example, because of the change in government and all of that, you are not sure how this is impacted or impacts.
Okay.
How do you cater for those?
All right. So now we're going into the asset management of it. So asset management, and once again, I don't know, let me be more Nigerian than Ghanaian today. You have an asset management system, and I'm sure, and that's what you use for your road fund, your maintenance. That's your decision support. That's what you use for your decision support. So, unfortunately, in my country, we pretend we have it. We pretend we are using it. But in principle, the decision support is mainly by politicians. Okay, thank you. Okay, yesterday I was told a joke. I don't know whether I'm permitted to say. It says that if you find a population of Ghana and you find a population of Nigeria, whatever ratio that you have, if it's 1:7, every problem we have, we should multiply it by that. And I don't know who said it, but okay. Yeah, I remember it, and it stuck in my head. Well, and so that is the challenge that we have. But I always say that, and that's why in Ghana I'm pushing for wigwams, and it's not because I'm going to get anything in it, but I believe that one day, and I have more years ahead of me in the public service, one day I can prove to a politician that based on this data, we've been taking the wrong decisions. That's all. So what you said, yes, so you can, this is only for a road, but the bigger thing that we are dealing with is a network, which means you need an asset management system that is able to help. And actually, that's what you talked about. When we were talking about AI, actually, if you have an asset management system, you can use AI, or you use the right term, or the deep learning. Am I right? You can learn from it and say that, especially when it's historical, it's able to tell you that this year, this were the total routing. This year, on this network, this were shoulder drop-off. You have all those distresses. And then it's able to tell you that if we don't do this, this will happen. That's asset management. Now, this is a specific road. And it's telling you that based on all the other information I have from your asset management that we've put into it, this is what is going to happen. This is the maintenance cycle. This is all things being equal. So you can pick that and look at the budgetary implications and use it also to advise. But this is for a specific. But I get your question as more for a network, which means you need a proper asset management system. I think in the long and short of what I'm saying, having an asset management is a tool. It's a decision support tool, but beyond it is the willingness of the people to use the tool. To let the tool decide for you. I think that is the challenge we have. It's not having the tool. It's allowing the tool to make decisions, or allowing yourself, let me put it that way, to use the tool as to make decisions. And sometimes that's what's this thing. There can be a political cutoff that, okay, based on this, we look at some politics and include politics and other things even into the tool. That if you have an asset management system, we can say that, okay, whatever prioritization that comes, 10% of it is for the politician. He will decide on how to use it. And the 90% is the software that is telling us. Or even 20%. But most often than not, now it's like we have the tool, we throw the tool away, and now we want to use the mind. But Prof said something that struck me. You see, as data becomes bigger, our brain cannot be accurate, okay, in doing a lot of the predictions. So be it no matter what, even you as an experienced engineer, if you don't use a tool and you say, okay, let's do this road, let's do this road, let's do this road, let's maintain this road, you get it wrong, because now the network is big. Even if you are a district or engineer, I'm sure your network, the number of rows that you are dealing with is still, you are dealing with a lot of rows, and you need data to be able to help you do that. Please, are we on the same page? All right. Sorry, I used the multiplying factor, but I hope no one is offended. All right, so let's go to the next. So here we are still talking about distresses. We know what distress is, and all these things are predicted, shown within the system. So they've actually developed distress functions or transfer functions within the MEPDG, which you can use. Or if you have developed a lot of data, you can even go in and modify those equations to meet your specific country requirements. So I think this we normally will measure roughness and roughness relation between the condition of the road. He talked about PCI. We can use IRI as a distress distance. So these are the distresses, whether it's rigid or flexible. These are the distresses, the common distresses that MEPG will distance. Now, if there are peculiar distresses that are predominant in this thing, and you've done a lot of research, and that's why the reason why I love this system is that if you start collecting data, PhDs, you can get a lot of masters and PhDs from, because they can collect data and say that, no, based on the materials within Nigeria, maybe this is the distress transfer function. I don't know whether that alligator cracks, the factors that affect alligator cracks in Nigeria is maybe traffic, this, but this is the impact. So there are a lot of those equations there, and then someone can work on those transfer functions or equations, let me put it that way, and come out with key distresses and put it in the software. And so that's when you are doing with the calibration of the software for your country. So with that, I think I've tried my best to introduce, these are the analysis, multi-layer system. These are school. I talked about the mechanistic, how the analysis are done. And now there are advanced analysis that you can use, but it's actually implemented in the system. So FEM is actually implemented in the system that is able to give you your stresses, your strain, and deflection at different temperatures. Those of you working on this, you can look at a simple software like Plaxis, model your asphalt within Plaxis and compare it with MEPG. You say Plaxis. Oh, Plaxis is P-L-A-X in xylophone, I-X. Yes, but you can Google it, everything. So the most common ones that I advise if you are using FEM for the PhD students is Plaxis, Abacus as in Abacus, and Adina. Adina is spelled A-D-I-N-A. Adina, yes. Please, someone should Google if I got the spelling wrong. Adina. It's at least the first, you can get the first 900 notes for free, so you can practice if you are a PhD and do finite element. Even Abacus too, I think you get around 900 or 1,002 notes for free. So you can model with about 1,002 notes, and it's for free. Has someone found it, just to confirm so that I don't? Yeah, Adina is right. And Abacus, you found Abacus. And Plaxis, yes. So I got it right. It's been a long time since I did some of these things. All right, so on on that score, if there are specific questions. So what I've tried to do, this is a system that is being used elsewhere. I want to re-emphasize a few things again. It's mechanistic, so it applies the mechanics of material, stress strain, basic Buzinics, basic Bemister principles, multi-layered system. It then uses experience and is able to then predict failure, not just failure, distresses. You then get outputs such as your layer thickness, your mist properties. So no design gives you mist properties. In all ASTRO and all those things, all that you get is thicknesses and resilient modulus. How to go back and get those resilient modulus is up to you. But now it's able to give you all those properties and then tell you that use this. And then beyond that, it's able to tell you that if you get this, this will be what you should be observing in 2 years' time, in 3 years' time, in 10 years' time. So all those things. So that is the whole concept of MEPDG. And on that note, I will pause, and if there are any questions, further questions, I'll take them before. I think I'm still within my time. I have 7 minutes. Any questions? All right.
Thank you. So, well, I don't know if this question is coming earlier than needed, but I feel everything you are saying is based on things that will inform our decisions in managing and sustaining our assets, right? So if that's the case, as an experienced engineer, will you recommend that a certain percentage of the contract sum, having seen the need for maintenance, during the design life of a project, say for 10 years or 15 years project, will you recommend that a certain percentage of the contract sum be set aside for the purpose of maintenance that you have envisaged, and this be part of the contract sum, so that at the end of the day, we don't have to wait for another government to come and to say whether we need to do this maintenance or not. I thank you.
Please. Yeah, I think the initial one, it should be, the renewal is around $5,000 or $7,000 annually.
All right. So, you can recommend that for NIBRI, Federal Ministry of Works, and FEMA in our communique. You recommend that FEMA can have at least the family one for 40,000.
Yes, so that'll be, I think the initial one is around 40,000.
Yeah, then NIBRI and the Federal Ministry of Works. Because the cost of these things that keep people aware.
Yes.
Yes.
But you need to renew it every.
Yeah, they should be.
Yeah,
That should
every
be in
year.
their budget.
Yeah.
Every year you should have that in their budget. Because
Yeah.
the younger engineers will use
We'll learn from them.
Yes.
Okay. And I think they have, that's why I wanted someone to check online, the ASTRO MEPD, because if you are buying it also in group, it's cheaper. If you can buy for about 20, no, go ahead. No, give us the information.
And then 67,700 USD for 20 concurrent users.
So if you are buying for 20 users, it's 67,000 USD. Okay. And 10 people is how much?
9 is 35,000.
Nine is 35,000. So I think then the single user is,
The single user is 9,000.
no, okay, so the single user is 9,000. So it's
9 units, 9. That's 5,000.
35,000 for 20,
No, for 9.
for 9, sorry.
About, that's about 50-something million.
Yeah. All right, sorry, let me answer the first question. So if I got you right, yes, you are right, but you see, I get the impression that you're saying, well, let's use contract to solve the problem. And you are talking about long-term contracts. Setting it aside, governments can always go in and use it. But if if you can look at long-term performance contracts, that could happen. So, for example, the performer OPRC is a long-term contract. Depending on the nature, you can have a 15-year, 20-year contract. That will solve this problem. But are we? It's okay. Sometimes I say that, are we really, so far the success story of OPBRC and performance-based contract has been pushed by the bank, the World Bank, and our development partners. But my question is that on our own, are we really prepared to do performance? Do we have the institutional structures to do performance-based? This, and I say this, I don't mean evil. Are we really prepared? Sometimes I feel that we are not, and because I was on OPBRC contract in Ghana. I was spearheading the one for our department, and I realized that even per the structure, after the projects, we will not continue. And we do not have any plan. It's okay, World Bank has brought money that we should pilot this. So we are piloting it. But when the money leaves, we did not start having those institutional changes to deal with that. And I see the same for a lot of the things that we do. And it requires a lot of, let me say, leadership reorientation. So I agree with you, but maybe we need to use another approach. Yeah.
World Bank guided it in Liberia.
Yes. Yes. Precisely. Mozambique, I mean, I've met some Mozambique, and they tell me the same thing. It's like the success story of OPBRC in Africa. It's because we have someone always holding our hand. Please, Doc.
Okay. So, thank you, Doc. So mine is going to go to the Professor Amin and then you. So usually for this data collection, we need money, right? So data collection for materials, geotechnics, quality control, and the lab work. So for Ghana and USA, we want to know what percentage of the contract do you actually use for this purpose? Because it's a controversial something in the ministry that they are not really funded like that. So I want to understand from your own case study, what amount do you actually budget in your contract sum? Thank you.
So I'm sure Prof will come in, but so unfortunately, we don't have a proper earmark fund for that. But I think yesterday I tried to deal with it. You see, there are, to quote someone, there are so many ways to kill a cat. And you see, this should be, yesterday I said you should start small. But I'm changing my position without saying that don't do anything. We should have a clear picture at the top of data collection, why we need it, what we need, and then it should trickle down. We can even build it as part of our contract, that the contractor, for example, data collection, for example, construction data collection, it's just about changing one or two clauses. You can decide not to spend anything. Change your contract in such a way that as part of the taking over requirements or the requirements that the contractor is supposed to do, they should give you data in this format. You want material test in this format, everything, because the contractor is supposed to do those things. And it should be verified by your engineer. So you don't need to spend anything. They will build it into the contract clandestinely. But it's how that's what I'm saying, it should be a top destiny. You should understand that we need this thing. So sometimes we request for as-built drawings. And as-built test result, but where do we even keep them? Sometimes you are looking for, we don't have any asset management system to input all those as-built drawings and all those things into it, so that when you click a button, you can say, oh, this project, these are the as-built drawing, these are the as-built test result that you can use for this thing. So at the top level, there should be a clear understanding of what you want. And then you can use contracts to deal with it. You can actually use contract, and the contractors will employ people. They will factor that in their cost. Without you going to the federal government saying that I need X amount, 30 million for data collection. Actually, that 30 million has been built into different contracts by just changing few clauses in your contract documentation. And I think with that, we can change the narrative and we can change the story. That's one aspect. I don't know, Prof, if you want to talk about. Okay.
Good afternoon. I just want to add a point, sorry to take us back. The last question, I thought you would go on that line, asked in terms of maintenance. Yes, it's the OPRC that we discussed about the output performance-based road contract. And I think here in Nigeria, we have done one, Kaduna and one, was done under output performance-based road contract. And this contract, the maintenance is inbuilt with the contract. As you are doing your contract, you are also maintaining the road. I think that's what they are trying to do with this, because this cafe, as you are building it, there's a service level. For each month, you will be assessed on what the performance of that road 1 kilometer. There are levels you will check, and then you will be, when the road is as good as is required, you get your money. When it is not done, you are kind of surcharged. So if you have 50 kilometers, so as you are finishing 1 kilometer, 2 kilometers, until you get to that 50 kilometers, the money is built into the contract, like he's saying. It's not that you just go and look for money to come and maintain the road again. It's part of the original contract. So I've done one in Kaduna under the World Bank, and some of us are part of it in this program. So we have an example even here in Nigeria. But because of the government influence, they want the traditional contract where they have influence, because this was done under World Bank. So because the traditional contract is maybe, they like it, up till now, we need more reform. It's the reform that we should have in this country that will make us do, because the performance-based road contract is what is done all over the world now, so that you move away the maintenance and other things from government to the contractor. So I just want to add this background to the question he asked in terms of maintenance. so that we don't lose that. We have we have is an example. We can go and study the Kaduna Round 1 under the World Bank. Thank you.
Just additional stuff. Yeah. When we did our World Bank, we advertised for under-specialist work when we were under RSDC, but the contractors refused to bid it for it. What they call it from Enugu Abakaliki Road. They bid the document we prepare. We spent almost 3 years preparing the document and everything, bidding. When they asked the contractors to bid it under Ministry of Works, they refused to. Yeah, because they don't understand the risk was much, and for them, and they can feel that they cannot take it.
Yeah.
Yeah, no. What I'm saying, maybe you need to go back. What I'm saying, the federal government under our program. There was a program, we did it, we spent almost 3 years preparing the document, we advertised and everything, the contractors were shortlisted. When they see the content of the decision, they refuse to participate. Thank you. Under World Bank project, thank you.
Yeah, so maybe just to make a comment on it. Yes, so it's about shifting risk. And the contractors, depending on, let me say, this, because I've been involved in OPBRC, I can say that one of the things we do not consider in OPBRC is culture, construction culture. Even the contractor, the understanding of contracts. Maybe they've been used to so much red book contracts for a long period. When you are bringing a yellow book, a silver book, because that's where OPBRC lies, contract, naturally you will have the results that you get. They are not willing. Am I going to take all this risk? For the public, those of us in the public service, it's good for us. But the contractors, how do you prepare them, even the organizational structure, to be able to do performance-based contract? And I think maybe NSC can take it up and do more training, even for contractors. If you train them and the government, let me say, the states and the federal government can help, so that the contractors understand, because they need to change. To do a performance-based contract, you need to change even your mentality. And for the management of the contractors, even for the engineers, because here we are measuring performance, not input. So yes, thank you, and there's the output. So nobody will come and measure, did you do 1, 2, 4 for your concrete? That's the difference. Your compaction meets this. It is the results. Is it performing? When I come and my rat's depth is more than 10 millimeters, I'll deduct, or I will not accept. That's the difference. So all of a sudden, a contractor thinks he's done a very good road. Then you come for your acceptance criteria, and the person, you say it doesn't matter because per the contract, this is what we want. It's the output. And once again, even for us, we need more education, because how to set the output specification requirements, sometimes we also get it wrong, and the contractors play. Those who are very good can take advantage of us. Please, you can go ahead.
Good afternoon, senior colleagues and my colleagues. Thank you very much, Doc, for a good presentation. My question is the ashtole wear. Can you use it for rigid pavement also? Because I see that you were quiet on that. You talked about the flexible, but on one of your slides, I saw that there was a good tick, tick, tick on it. So I just want to know and the procedure. Thank you.
All right. This one, my apologies. Yes, you can use it for all. You know, that's why I said that it's not only for HMA and PCC as in the ashtole, but different types of pavements. And remember, I showed that diagram that showed even within the HMA, different combinations, with additives and all those things. So you can get the fundamental material properties, which we talked about, the E, the Poisson ratio, all those things, and even input it into it, and it can help you with those predictions. Okay, so yes, my apologies. All right, any other? Okay, please.
Thank you very much, sir. Your design program, does it incorporate asset management in it? Can the software tell us, like you're saying, that at so period, this road should be maintained, and also predict the cost of maintenance?
So that's why I think it was his question that I tried to bring. So this is for a road. Now, when you are dealing with asset management, you are dealing with a network. Do you understand? A network, and you are looking at so many factors. You are dealing with prioritization. You are dealing with costs. You put cost input, unit cost in it. What is the cost of maintenance? And you can do that prediction. This is not an asset management software. It is a design software, but it incorporates predictions also. That's why I was saying that at the end of your design period, maybe for 20 years, it can tell you that this will be your total crack area. Do you understand? And so, yes, it has that capability, but it's not for proper network asset management system. Please, I hope that is clear. All right. So on that note, thank you very much. I think there are no more questions. So I was standing between your lunch.
Please, a round of applause for Dr. Patrick once more. Ladies and gentlemen, that was a wonderful one. Mechanistic Empirical Pavement Design Guide. So please, let us stretch ourselves before we go to the next segment of the training. Can we just stretch ourselves? Just stand up, do some stretching. In fact, walk to 3 people, not on your table, no, and tell them in your dialect what pavement is. Make sure you tell, I will ask questions, so 3 persons not on your table, what is pavement in your dialect? So it will be you now. So what's pavement? I don't know. So your time is counting. 2 minutes. Stretch yourself, stretch your legs. Don't go out, oh. Just stretch your body. 30 seconds more. Raise your hands, stretch your legs, start getting close to your seats, and start sitting down. Thank you. So now we take the 3rd course. After that, we would have our lunch break. And please, as you are stretching, watch the registration table and make sure you write your names as you would like them on the certificate. Let us please be seated as we now go into asset management systems, pavement management systems. And that will be taken by Dr. Amin Aknok. Thank you. Let's put our hands together for him as he comes up again. Thank you. Please, let's sit down now. Let's have some quiet. Yes, when you sit, we begin. Let us sit down. They are going for prayers. They'll come back. So let's sit down. Let's have our seats. You know, anytime we add now is when we close. Thank you. So, Dr. Amin, you have us.
Sure. Welcome again.
Yeah,
can we have them upload presentation? The people at the end, just to upload the presentation.
Okay. Make way, can we have the presentation for the asset management system?
Presentation 3. No? Okay. So, welcome back, everyone. I hope you are still following. Hello? Everybody's here? Attention, attention, attention. Okay, so we're going to start our presentation about pavement management systems, which is one of two major types for asset management. You know, we're always talking about PMS, the pavement management, or BMS, bridge management. And I'm glad the last question that Dr. Patrick answered to about doing optimization or design for a project level versus network level decisions, that is the exact roadway or the connection between the MEPDG and the asset management. So in short, asset management, we are trying to think from a holistic approach on a network level so that we can come up with the right decision, whether it's a design decision or a repair or maintenance decision like preventative, like reactive maintenance decision, or corrective maintenance as some sources call it, or if it is a preventative maintenance or a preservation decision. So going into PMS, I'm showing here some of the outlines that will be included, how to define or what is a PMS entailing, the major principles or components for the PMS, network versus project level, then the subsystems or subcomponents or modules that form a successful framework of a PMS, and then how to do the evaluation on a project level. You know, again, multiple project levels will add up to form a network level. And then I'm going to touch the economic repercussions, and my colleague, Dr. Patrick, tomorrow is going to do a presentation about life cycle cost, so he will elaborate more on this. So, a general definition, and I hope you can read it. You all read English better than me, but you know, a good pavement management system, it is more or less a tool. Consider it like a software or a bunch of algorithms Now we're very familiar with the terminologies. So basically, it is a tool where you can rely on the massive computational powers of, supercomputers or powerful computers, let me put it this way, to generate or provide you with timely decisions. Technically, it should be correct because that relies on a lot of historical data that is already fed into the PMS or the BMS, and that help you predict or extrapolate. So you can somehow foresee or read into the future. Then you can basically, based on this forecasting capabilities, you can come up with the correct decision in the right time. So talking about the components of pavement engineering in general, think about these. We first talk about pavement materials, and we have had enough about this. Flexible pavement, including hot mix, warm mix, cold mix, right? Rigid pavement, and I here primarily mean Portland cement, concrete pavement, and RCC, the roller compacted concrete. There are classifications, there are quality assurance, and there is, all types of work that leads into materials selection and design. There is pavement design, there is the construction process itself, and then comes the role of management, which again, it is a post-construction. Now, is it only post-construction? Think about it this way. Based on the pavement management systems and thinking of what Dr. Patrick was talking about, you can take advantage of this data on a project level, not on a network level, so that you can decide which way you would go for your design. Should I go flexible? Should I go rigid PCC or rigid RCC? What type of thicknesses, what type of material quality, all this based on the mechanistic empirical design on a project level, right? Same data, collecting multiple projects or multiple individual projects. Let's again think of bridges. You have 623,000 bridge. Every one individually is a project which can be treated at its own on a project level. Then the collection of all this, or the collection of 4 million miles of pavement, their conditions, their history, the material, the traffic, the temperature differences, the hydraulics, drainage, amount of rain, amount of snow, you name it. These are all combined. Every dot on the AI, the regression model, every red dot on the regression model is a project level decision. And then all the dots together are combined using algorithms and machine learning to provide you with what a pavement management system or a bridge management system, or together an asset management system, are supposed to provide you with. Finally, the last component down there, it's research, because as I said earlier during, if you noticed during my AI presentation, it's a dynamic process. Developing a model, you develop the model, you keep updating the model, retraining the model. Like let's say regression, you have data points and then you have that line. Clusters, you have data points, right? And you have the clusters based on the centroids. Now, is this data points static? They are not. They're static for the moment. Few years later, based on new technologies, based on new maintenance procedures, based probably on budget availability or budget restriction, or based on global changes in, on Earth, then the points can shift up and down, left and right. Then, because of this dynamic nature, research has to be considered. And new properties, once you develop new material, all this has to be updated, whether the MEPDG, Young's modulus, Poisson's ratio, gradation, right? So all this are gonna change, so it has to be changed on your software dealing on a project level or on the holistic approach or the network level, which is the asset management system or the pavement management system. Is it clear so far? Yeah, I know everybody's probably tired. You're probably looking, waiting for lunch, but please pay some attention. I'm kind of trying to tie up what we talked about in the last couple days with artificial intelligence and machine learning of early morning today, then what Dr. Patrick talked about. All of this are tied into this. This is the holistic approach that combine historical data, machine learning, mechanistic empirical, life cycle cost. It's all come into one on the asset management, whether bridge or pavement management. So think about this diagram. What is it basically telling us? This is a schematic. You do have, from the bottom there, you do have data, you have project files, quality control, quality assurance, then you have database for materials and construction, database, again talking about materials from performance standpoint, cost-wise, because here one of the differences between the mechanistic, empirical, and project or pavement management or asset management, this gives you suggested decisions. Suggested decisions, it's not based only in performance. Like what Dr. Patrick talked about, you're basically in design looking for best performance, right? Here, it's best performance given the level of funding that you have. So you're having some capping on your ability to make decision, because this is not an individual project. You're talking about a road network of several thousand kilometers. You're talking about few hundreds or few thousands of bridges. So if you say, I'm gonna need the best, well, good luck. You're gonna do 2 good projects. What about the rest of the network? The budget is over. You don't have endless support or endless financial support, huh? Any questions here? Okay, so again, I'm not gonna go into this, but you guys, basically these are all definitions that I bring from the Federal Highway or from AASHTO. It's all scientific decisions, so anyone here, like let's say we'll do a press release, publish a paper, do masters, do PhD. I mean, these are the definitions that you can use in your publications. Now, what are we, or what's the end of this headache? You know, we're collecting data, we're doing inspection, we're doing machine learning, algorithms, mechanistic empirical. Then how could we get this into play? What are we supposed to do? As I said, the whole story stems from budget limitation. Limited budget means that you really know what's the best decision. You really know what's the best practice. Best practice for designing a new project, best practice to maintain an existing project. However, because of maybe human resource limitation and definitely financial limitation, you need to work or do the best given this constraint. It's like, you know, think about a head of household. You have a specific income. You want to get your kids the best car, the best education, the best travel, the best clothing, the best medical, but you don't have enough funding for this. So you start mix and match. Maybe one area I'm gonna totally skip. Another area I'll accept 50%. Another area, no, that's, I cannot afford to not be treated. I have to spend money on medical and so forth. That is exactly what's going on here. The main function is, as I said, if you're talking about 1 bridge, 2 bridges, you can do that manually, you can do that by an Excel spreadsheet. However, talking about hundreds of thousands or millions of miles or kilometers of highways, you need this to be computerized for you. That is what your pavement management system is going through, the forecast or forecasting expected conditions. Under what? Under different designs, which is provided through what Dr. Patrick has said, and under possible funding scenarios. What does this mean? This is not only talking about initial cost and initial design. It's talking about how much maintenance or preservation you can do along the years to a very large network of roadways or a very large network of bridges. If you have endless funding, you really don't need this. The golden rule is what? Any problem, treat it. But when you have 623,000 problem in 623,000 bridges, and the money is only enough for 1/3 of this, which one you will do first? Is it the worst first? Traditionally, that was government attitudes. You start by the worst problem, fix it, and go up. Now, they discovered with research this is not the right approach, because if you only focus on the worst first, by the time you fix the worst, you would have, let's say, 50 projects that are bad, you fix them, and you didn't care about 250 good projects. By the time you fix the 50, you will not only find another 50 bad, no, you will find 150 bad ones. Then the money that was enough to fix the 50 is not going to do you any good when you talk about 150. Then that's why you have to think of part of the money goes for the worst first, which is crisis management, if you will. Like, nobody would like to have extensive rutting that causes an accident. Nobody wants to see a structural failure. So if you are on the verge of collapse, no one would like to open the newspaper or listen to the TV and find like a roadway collapsed or a sinkhole happened or extensive rutting, diverted traffic and people died, or a bridge collapsed and people were on the water, right? So this is part of the money that goes to corrective maintenance or reactive maintenance. And this is usually spent based on the worst first. But because you cannot spend all the money on the worst first, you have to define which one is the worst among the worst. This is a network level decision by PMS or BMS. Then the remaining amount of money would go for not corrective maintenance or reactive maintenance, it will go for proactive or preventative maintenance, where you try to delay the level of deterioration on the good ones. So you don't wake up a year or 5 years or 10 years from today and you find that, well, I've been fixing 50 bad bridges per year over the past 10 years, now I have 250 bad ones. What am I gonna do now? Because the funding is never gonna grow, or, you know, the deterioration, in other words, would outpace the growth in funding. I'm not talking about African countries, I'm not talking about Nigeria, I'm not talking about Egypt, I'm talking about the US, I'm talking about rich Gulf states. Call it, you know, Dubai, call it, you know, United Arab Emirates or Saudi Arabia or Qatar. We are all in the same boat. Population explosion, size of the projects, mega deteriorations. So no matter how much funding or increase in funding, even assuming the stability of the exchange rate of the money. You know, here in Africa, I know in Nigeria you had depreciation, in Egypt we had depreciation, that's another challenge. So this is basically what the asset management is trying to tell you. For a network level with thousands or millions of kilometers of roadways or thousands or hundreds of thousands of bridges, how much of the money you have would go to the worst first? How much of the money you have would go to the best first, or, you know, preservation? And out of the good ones, which ones are the best? And out of the worst ones, which ones are the worst? To give or to make prioritization. Please look at this chart, and tomorrow Dr. Patrick would include this, but this is basically how life cycle cost analysis is all about, and this is how pavement management systems or bridge management systems are all about. You basically collect or do one of these charts for every data points. If you have, again, 623,000 bridges, you have 623,000 dots on your regression model, and you have 623,000 of this charts. Same for your highways. You can split them per roadway or per sections or per kilometer or however, or you name it. But every division, every small portion, every project level would have one of these charts. Now the $1 million question, how do you draw this chart? Can someone answer? I mean, what is this chart showing us? We have, again, on the x-coordinate, let's use terminology from AI. Is it independent or dependent variable? Huh? Independent, horizontal coordinate, or x. The vertical, it is the dependent. So mostly here, when you take decisions versus time, like in PMS and BMS, it will be time factor, that's what you care about on the x-coordinate. After how long will the condition on the y or the dependent variable gonna go down? What is the slope? Is it so steep or is it so mild? That's the first thing. Now, how steep or how mild? Where do you bring this from? Because you don't do it only for previous data. PMS wants to predict future expenditure, right? That's why we use it. We're not using it to predict something in the past. Something in the past you already have the data for, right? But you want to know, if I build this roadway using this type of material, this type of design, or I build this bridge using this structural system, this material, how much will it perform? Remember, for bridge, it's a 100-year project. So you want to draw this now for until year what? We're 2025, then 2125. So how would you do that? That's AI back into play. You would take advantage of all the previous data points. Remember, data. So you have to have a start point which is collecting as much data for how far back you can go. And based on whatever this performance come, you can predict or extrapolate into the future for whether existing project, how they will perform in the future, or even to think about new designs. If I designed it this way, how would it go? Like this or like this? See, that's here a combination of data collection or inspection, artificial intelligence, mechanistic empirical, and PMS or BMS. So here you can see multiple scenarios. There is the original curve, the big one, going all the way from best down to the worst. Or there are some like curves up. Can you tell me what are these? What is meant? Did you see what I am trying to point at? The main big curve or the other zigzags at the top? What are these? Exactly. So if, let's say, you decided to do nothing, this is a do nothing scenario, the big one. This is how your project, whether a pavement or a bridge, would perform. Now you can see that you have a specific deterioration level that is not that high up front at the beginning, first few years. If not treated or not preserved, what's going to happen? It will have a steep drop. You know, the easiest analogy I can make, it's, do you remember stress strain curve you draw in the college where you do a pull-out test for a steel bar? You remember the stress strain curve? You go through the elasticity, it go like that. You know, stress over strain is constant, that's the modulus of elasticity. Then you reach to a point, do you remember this point? Yield point. After which, a very minor change would result into dramatic elongation or dramatic strain. That's exactly the same. It's the nature, how God created thing. Even look at our human body. You can sleep late, eat unhealthy. As long as you're young, your body can rebound. You're regenerating new cells. You reach to a specific point, you'd find every year a new disease and new illness is bombarding you. Unfortunately, that's the nature of things. Same for materials. So the decision is yours. Now, should I? Well, everybody will say it's a no-brainer. Then let's do intervention as early as possible because you will spend the least and you'll preserve your network condition or your project condition in the best possible shape so the commuters, whether commuting on a bridge or a roadway, will be happy. Sounds like an easy decision, but why don't we do it? Why don't we preserve? Because technically, we're not starting All the bridges are not at the same day, at the same age. All the roadways are not at the same age. Let's say you're deciding to do your decisions now. Are all your bridges on 100%? Are all your roadways in 100%? No. You'd already inherit a bad inheritance. Some of the projects are already halfway through their lifespan. Some of the projects are towards the end. So if you keep preserving the best ones, how about the bottom ones? People would die. So again, you have to balance or weigh your options. Can you do this? Well, on a one project you can, 2 projects you can. It's like when you run your own budget at home. You will not buy a home management system per se. You can do that because you have, you know how much money you have and you know what kind of expenditure. That's a small entity. But if you talk about hundreds of thousands of kilometers or bridges, no, you need a help, right? So basically, how would we go? Again, I'm not sure about Nigeria here, but in the US, the vertical is the condition. So on bridges, we go 0 to 9. That's what the AASHTO is telling us. 9 is the best, going down all the way until 0 is the worst. In roadways, we go 0 to 100. The PCI, or Pavement Condition Index, again, 100 is the best, 0 is the worst. Some of the countries, they have what they call like a benchmark level. They have a political decision. If we reach up to this, then we have to find budget to fix. So let's say wealthy country, maybe they say, oh, we need to pamper our citizens. So we cannot accept our roadways, the PCI to go below 80. They will draw a line at 80, horizontal line. Any bridge or any, pavement on the network that goes down, once it hit, that's a trigger. Again, think algorithms. This is a priority project. We have to find some budget, right? That's if you are wealthy enough. Some other countries, you know, people are like hand tight. So you end up providing the amount of money, how many millions of dollars. That's what we do in the United States, by the way, how many millions of dollars you have on a state level. And then the network in the state, like, you know, I said 623,000, that's a federal. In my state, we have 19,200 something, I don't remember. I can't keep up because every couple days there is a new bridge, but we are 19,200 and counting. So we enter this 19,000 bridges to our BMS, right? And we provide the level of funding that okay, and then we get, according to the level of funding, we will get the best possible scenarios for how many bridges or how many miles of the roadways should we consider doing preservation for, and how many should be maintained or even replaced. And keep in mind, not all the preservation activities are the same. Tomorrow we're having a presentation, a standalone presentation about different tactics you can do for preservation. Everything comes at a cost. There are some activities that you can do to stretch your livelihood by a few years or more. So of course, the higher or the stronger the intervention, the higher the cost. So that also has to be fed into the computer. You don't only let the computer know how fast it will deteriorate, but this type of activity would help extending X amount of years in your service life, but it comes at X dollars or X nairas or X currency cost. Then you get these type of scenarios. Every different color here is a scenario, whether it's a preservation scenario or a maintenance scenario or a mix of both. And as I said, there is weak AI. The power of the PMS or the BMS stops here. It's giving suggestions. Whether you take it, fine. You don't take it, also it's up to you. However, once you do an activity and you do any preservation or any maintenance or any new construction or replacement, you better off go back and feed it to the system, so when you do the next cycle for the next year, you start from where you ended. Because again, the computer cannot know which activities did you do and what's the current level of the network. Oops. So, we sound like we're going in circles now, but always keep this in mind. Network level and project level. In PMS, you can do the same. MEPDG, we're working on a project level. Here, you can do a project level where you can basically compare option A versus option B, whether you're doing a new design or maintenance and preservation. But then you cannot think independently. Project level, it could be a decision for what we call a division engineer or a section engineer who cares about one project or a couple projects on his region. And of course, if you leave it up to this type of engineers, they will do a great job. However, they will absorb all the budget their way. Then you'll have a fight between section engineers. Everyone is pulling the resource. For him, everyone wants to be good, right? But then comes the upper management, upper layers, all the way up. They will say, hey, guys, calm down. You make your case, you make your case, you show me what you have, you show me what you have. At the end, I'll try to do my best to satisfy you, but I can't promise that I'll do everything because I don't have money for everything, right? So that's why the project level goes up to the network level. But the good news is, at least when you request money, whether you are down there or up there on higher level or senior level, you have a case to provide. This case is, if you give me money, I'm going to do this preservation, the curve would start to pick up like this. If you don't give me money, the curve is going to break down like this. How can you know it's going to, because 25, 30, 40 years ago, before PMS and BMS and AI, let's say a small engineer talks to his boss and he tells you, how could you know? Because you don't have data, you don't have any history, you don't have algorithms to predict for you. Now, you can make up your case. Then you leave the decision for the higher ups dependent on how much funding they can provide. And by the way, we have this never-ending fight in the United States between different states. Every state wants, because there is state funding from gas tax and tolls, and there is a federal funding from the appropriation from the FHWA. Then every state wants to take the whole funding from the federal to itself. So they try to keep, we're going to have hurricanes, we're going to have earthquakes, help us, help us. Everybody is trying to make up a case to attract as much money as possible to improve their network. So as I spoke, the project level approach is there. You can do priority assessment for sure. And then the network level approach is there as a combination of the project level. Now, what do we need? Because a PMS or a BMS or asset management, that's an expensive piece of software. I remember back in the days when I was a new immigrant in the US, the federal government was literally running with a stick after every state DOT, trying to push them to implement this technology as much as they can. And there was a resistance for several reasons. Main one is upper level management. They have spent their careers doing it in a given way. Now we're close to retirement. Why would we change? There is a level of comfort. People are always against change, right? That's one reason. It's a human psychological reason. The other is initial resources. I mean, it will help you save along the road. but it's expensive software, and you have to do expensive training. And then having the software without having data is meaningless. Trying to have data using visual inspection, as I talked about yesterday, is meaningless. You have to buy GPRs, LiDARs, thermal cameras. Then if you buy this, buying this without training is meaningless. So it's a big cycle. You have to have training on using equipment, then you buy the equipment, then you do the data collection, then you store the data. Bang, you can start now. Sigh of relief. I have the system, and I have what it takes to make it work. So first thing is your inventory. What's inventory? Everything you have about your pavement, about your roadway. The length, that's one thing. The lanes, number of lanes, another thing. The width of every lane, type of pavement, thickness of every layer, percentage of binder, gradation of coarse aggregate and fine aggregate. Do you have drainage or not? Slopes. Current condition comes after that. Current condition means you have had inspection for every little bit of your road network and every element in your bridge network. Talking about roads, your PCI, pavement condition index, which is function of what? The roughness, IRI, the rutting, and the cracks. This is how we do it in the US. Of course, every country is more than free to develop the criteria that defines the condition, the y-axis. Remember, we talked about time, independent variable, condition. Now, in the US, time is time, like here, like anywhere in the world. And I'm lucky that, because when I moved to the US, I had a problem. I think in megapascals, in kilograms, in centimeters. They talk pound. And so I spent like first months in my graduate study. It's like, what are these people talking about? My concrete strength is 28. They're talking about 4,000. Well, it's 4,000 PSI, right? So you have to talk the same language within your boundary. So time is time. I remember my master supervisor, he said, well, you're confused in meters and kilograms and seconds and pound, but at least, and pounds, but at least you use hour and year and day in your country. I told him, yeah, this is global. So your x coordinate, your time, your independent variable, we're all agreeing on. The dependent variable, which you use your prediction against, which is the condition of your bridges from 0 to 9, as we said, that's how we do it in the US, or PCI, or some states, they call it PCR, pavement condition rating. So it's pavement condition index, PCI, or PCR, pavement condition rating. That's the y coordinate. This y coordinate from 0 to 100 in the US, and then every grade is given based on 3 factors. Your IRI, the roughness, the amount of rutting, and the amount of cracks. Maybe here you have another problem, raveling or whatever. So you can incorporate, you can develop your own matrix to do the evaluation for your condition index. So this is second step. Remember, we created the inventory. Then you have to do the inspection to determine which bridges or which roadways are on level X, level Y, level Z. So pavement data collection, these stresses, cracks, whether alligator, transverse, or longitudinal, comes into play. Predominantly, as I said, rutting is the second one. Third is the IRI, the roughness index, which is function in everything else, weathering, graveling, etc. So you grab this, and then basically you do the modeling and you try to come up with your evaluations as you see. You have how many miles or how many kilometers? How many of these miles score 80%? How many of these miles score 85? How many scores 50? And then you multiply the number of miles by the condition, then you add, then you divide on the number of miles. That gives you what? The overall condition rating on a network level. Is this clear?
Not quite clear.
Say it again?
Yeah.
Okay, let's say you have a network of 1,000 kilometers. 50 kilometers have a condition 95. Another 25 kilometers have condition 92. 200 kilometers are 70. Others are 60. Then what's the overall condition? You get the length, multiply the condition, plus next segment, length multiply condition, plus. It's like calculating a GPA of a student. How many classes he scores in A, how many classes he scores in B, you multiply, then you divide over 4 if the GPA is out of 4, right? So you do this, you come up with a number. This number is the overall. Remember when I talked about day one, when I said about the American Society of Civil Engineers, when they talk about the roadway condition and they give A, B, C, D, E. Not all roads are D when they say the average is D. Some are A, some are B, some are C, some, but then if the majority is D, then you're probably on the D range. That's the same thing you do here. Then, relational data and report generation. That is step number one. You had the software, you had well-trained people, you bought the equipment, you did a whole survey for the network in the country, whether a pavement network or a bridge network. You made data entry. Then the next step, what are the conditions, current conditions, right? And then you have to feed in using algorithms how fast it will deteriorate. And then now it's time for reporting. So some of the inventory data, and this is again based on what the AASHTO is telling us. It depends on the country, what level of details you want to go to. It's up to you. And these type of softwares, some countries like in Dubai, actually United Arab Emirates, they develop their own version. But if you buy commercially available PMS, you will have, it's like you have a data entry facade or web that you have to enter. So this is type of data required. The route number, the type, is it an interstate or US? You can classify local, collector, arterial, express, free, however you want. The class, level of service, length, pavement type, number of lanes, roadway width, shoulder type, shoulder width, legislative district. Because in part, you have to tie the decision to who is responsible. Could be municipality or the overall DOT or the federal. So again, it is however you classify things in your own country. Now, the evaluation. Pavement roughness, IRI, that's number one. Surface distress, rutting, skid resistance, and capacity. So this is how the flow of the work is going to go. You evaluate the current condition, determine rate of deterioration. Evaluation of current condition is easy. You do inspection, you have the current conditions, you inspect it. You evaluate it. As I said, how many miles multiply 80, how many miles multiply 70, multiply 50, you add, you divide. This is the current condition. Here we are, we stand at this point. Now, what is the rate of deterioration? AI. Algorithms, because you have X hundreds of projects that have this condition under this traffic, under this level of rainfall, under, and based on previous history, they deteriorate, let's say, 3 points every 6 months. So your curve is going to go like this. Or 6 points, your curve is much steeper. Or maybe 10 points. So you need to define this based on historical data. You determine rate of deterioration, and that can tell you, based on where you are today, the rate of deterioration predicted from algorithms, what will be your future condition. Now, what will be your future condition? Given the level of funding you have, what should I do? Again, should I start by the worst first, crisis management, to save lives, or should I start the best first? That is probably for future projections to avoid having mega problems down the road. It's like, you're sleeping, you're healthy, but I'll take vitamins, I'll sleep well. Why? Because I want to prolong my longevity or stay good for how long I can. So that is basically what this software or piece of software or commercial package is telling you. How you do that? Again, you can do it manually. Human observation. Remember the presentation of yesterday. But again, what's the point of buying a PMS. It is to deal with huge data, because you can't do it manually or with Excel. Then if you want to do work or business with huge data, then what's the point of doing manual inspection? It is like buying a Ferrari and trying to drive it on a low volume road with tons of potholes, and it's like, what are you doing? You have to have, it's like, you know, a chain. If you have very good chains and then one weak link, that's it, you're done. So these are some of what we have, again, like measuring the skid resistance, ground penetrating radar for what's below, like layer thickness, like voids, and the profilers, and this is more or less like the ARANs, which depend on LiDAR. So LiDAR is for surface conditions, GPR for below conditions. We had that yesterday in all of our preservation. Again, you know that there is no invention in here, but the ride quality or the road roughness measured by IRI is one of the pavement condition thing, the surface de-stress. So the rutting, how long and how deep the ruts are, and this is how you calculate them by measuring the depth. Skid resistance can be calculated to see if you are going to be a victim of hydroplanning, and this is very important thing in the US because of high speeds and because of the amount of snow and the black ice that is formed. So skid resistance is a huge factor in the US on the identification of the road and the bridge network condition. Then structural capacity, again, you can collect this data. Now comes performance analysis. What are we trying to do? Basically, measure the current and the expected future ride quality, the IRI, surface de-stress, the rutting and the increase in rutting, and the decrease in structural capacity. This is how you do rutting for, you know, like how to assess the rutting. How much you have, how long these ruttings are. Same when it comes to surface de-stress, predominantly cracking. What is the length of the crack? What's the width of the crack? What is the depth of the crack? And other, you know, de-stresses, again, we need to standardize because you're talking about a network level. Then again, in the US, they love specs, right? So they created identification manual so that all the states talk the same language. You cannot have a state that consider a crack with this length would drop you X points, another state, same length, drop more points, because at the end of the day, then the states are talking different languages. And what will the federal government do? They need to have same benchmark for all the states to be able to provide fair funding, right? So they have this manual so that everybody can see things with the same eye. Performance analysis. Now everybody understand what is this? Then you do have this black line, that's the default. Then you have the red line measured. Again, that could be change or difference between your estimate of the PMS and your real estimate. You go back and recalibrate. As I said, it's a dynamic process. The horizontal red line that I have the word trigger on it, that's when a decision has to be made, that no matter what the problem, you have to find funding. Whether it could be safety related, like people can die or accidents could increase, or sometimes it's a political decision. Like, you know, if some of you went to Dubai per se, they have, I think it's called Sheikh Zayed Road or Sheikh Khalifa Road, I don't remember, the one that takes you from Dubai airport all the way till Burj Khalifa, Burj Al Arab, that major road. It's like really a world-class facility, multi-lane, you know. So there is a political decision because all the foreigners, all the media, politicians, ambassadors, presidents, people visiting Dubai, this is advertisement for how good the country is. So this road, you will never find a pothole. no matter how many cracks, no matter how many vehicles you have, no matter how much rain you have, it always dries. So there is a political decision to raise the bar, the trigger level, because this is the shape, the figure of the country in front of the West or the other world. Okay, so that gives more priority. But again, not every road will fall under this. It's a political decision, as I just said. Again, different scenarios. Do nothing scenario, that's the gray. Basically, if I'm going to sit back and relax, this is how my asset would depreciate with time. Now, the dotted line going up, this is, could be a preservation, it could be a maintenance. What would define if this is a preservation or a maintenance? Can someone tell? That's a sneaky question. Like, is this vertical line up? We know there is something done, improvement. Is this a preservation, like proactive, or is it a maintenance, like a reactive? How would you tell? What is the difference between preservation and maintenance, if I may ask? Huh? Proactive is preservation. So, and reactive is maintenance. So the earlier this intervention is, or the higher the condition you are on the solid line, the more likely this is a preservation. Because you cannot preserve a road that is already deteriorated, right? Preservation, the motto is the best first. Maintenance is the worst first. So if this intervention, the vertical line goes up, where the solid line has already been down there, like if your PCI, in America they tell you, if the PCI, I mean, depends again here on the state. If it is below 70, then every action is going to be a maintenance, like reactive. Because it went below 70, it means you have extensive cracks, you have extensive ruts, you have extensive potholes. What are you going to do in preservation? You'll preserve it on a bad condition? No. Right? But if you are above 70, most likely this is a preservation, because you are still in good condition and you want to keep it as good as possible for how long you can. So the earlier the intervention is, the higher the likely it is a preservation. And what about this? It takes less money, it keeps you on a better or a higher PCI, so people are happy. And again, why don't you do it all the time? Well, because some of the network is already towards the end. So if you spend all your money on preservation, you'd end up with some collapses. But if you spend all the money down there, you'd end up with major deterioration in the future. So again, this is the dilemma, or this is the nature of the beast. You are using the PMS or the BMS to fight. Economic analysis. MYP is multi-year prioritization. Again, that's the help of algorithms and what kind of curvature would you have. So, of course, the benefits, you can forecast future condition. You can do analysis for options. You can do analysis for what type of intervention should you do. Should I do preservation? Should I do maintenance? If I do preservation, is it fog seal, slurry seal, chip seal, mill and fill, ultra thin bonded layer, FDR? All these are different types of preservation activities. Each one has a different magnitude, extends for a different lifespan, but costs you much. You know, you get what you pay for. Again, I cannot overemphasize how important this thing, but here what I wanted to show is at 75, which is fair condition, you still see not too bad of deterioration. Once you pass this, see what the slope is doing, you'll probably accrue a 50 points drop on your PCI or PCR in like 4 or 5 years. So this is a motive to somehow, of course based on financial limitation, to try to preserve as much as you can. Because what you are paying $1 for here can cost you, I can't read the number, but 7 to 10 maybe, I don't know. But it's telling you that every $1 you save up front will cost you much more at the back end. Right? So Health assessment, whoops. It's FHWA. You have to determine, that's again, as I said, every country is free to define its own matrix. Would you do it every mile, every half mile, every location, whatever. So federal highway, it's 0.1 mile section. So you calculate the index for every 0.1 mile and you average. You rank from good to poor. This ranking is based on, as I said, PCI or PCR. It's the IRI, the roughness, plus rutting, plus percent of cracking. Then again, it's a must that every state on the 50 states, if you don't do this, goodbye for the federal funding. The government is not going to see you. Try to find your own money. So all the states now implement this. And you have to define your own acceptable level of data quality. And that's why your data quality, you have to align the amount of training and the type of equipment you are providing your people. I'm here talking about little deeper details, how to measure the IRI, but you know, it's easy to find over the internet. I'm not sure, do we have time to watch videos or? Okay, so guys at the end, can you play the video, please? It's how to measure the IRI. As I said, you measure the IRI, you measure the rutting. IRI is roughness, then rutting, then cracks, then you assign for every 0.1 mile a condition, PCI or PCR. And based on this condition, you average for your network, and that tells you the overall condition. Is it not working? The video? I mean, I checked it on my personal computer at the hotel. It was working, but I mean, I don't know, maybe software issues or how fast the internet is sometimes. I mean, anyway, that was, the video was for IRI, the roughness index. You can find similar videos or even the same video. You can find it on YouTube if you do researching. You know, the FHWA, and I'm not sure if you guys are aware of the Turner Fairbanks Highway Research Center. This is the major highway research center in McLean, Virginia. Their website is super powerful, and they do have endless free report because it's taxpayers' money. They have to make it free. There is in America, they have the FOIA thing, Freedom of Information Act. So that's one of the things. Taxpayers are paying for this research, then the research outcomes has to be made public for the people. So take advantage of this, please. Turner Fairbank Highway Research Center, TFHRC. Turner Fairbank Highway Research Center. It's in McLean, city of McLean, Virginia State. You know, I was the IRF before, the week before this. I came flying from Washington, and we had a delegate from the Ministry of Transportation from South Korea, actually. And I did close by training, and they wanted to visit the Turner Fairbank. And the bus driver made a mistake. Entering the Turner Fairbank, he went to the next door. What's the next door? Can you guess? This is by the federal government. We're close to Washington. I mean, honestly, all the people on the bus were almost below the chairs. It was CIA. I'm serious. So one guy said, "Oh, CIA." So I told him, "Well, are you guys from North Korea or South Korea?" They said South Korea. I said, "Okay, stand up, no problem." If you told me North, I'll be the first one to jump off. But anyway, so it is a very nice facility, the Turner Fairbanks. Please go Google this. And they, by the way, they do have traffic research, material research, building bridges, anything, tunnels. So you take advantage of their library. It's a free resource available for the whole world, actually, not the US. Guys, at the end, you can't make it happen. You can't work it. If not, we can proceed. I mean, it's a video under IRI. If you can search in the YouTube IRI, you will definitely find the same or similar videos. The control is at the end, so. Guys, no problem. If you can't operate it, okay. So, anyway, it is a device, actually this white one, I think you have one here, right? It measures how the ride is bumpy, and that is calibrated to tell you how rough your surface is. So they are trying to simulate the level of comfort for the drivers. This is basically how they measure the IRI. Then comes cracking. Again, in cracks, you have to know, well, the level of the cracking, how long, how wide, how deep. I didn't bring. Is somebody controlling from the back? I didn't press when it went back. Okay, then crack measurement. This is another way. There is a laser system, the LCMS. It is dependent on laser scanning, and it can tell you the level of cracking based on the depth, the width, and how long it is. Again, if you Google this, I don't know why it's not in play. In my hotel room, it was working very fine. But this is basically how you measure your cracking. Then comes the rutting through pavement profile. And then as a combination of the three parameters, you can see here, good, fair. Again, this is RDOT, Arkansas DOT, Department of Transportation. As I said, the matrix is the same. There might be slight changes on how you average the numbers. Some states are worried more about rutting, some are worried more about cracks, because not all the states have the same geotechnical condition, which impact rutting. Not all the states have the same temperature variation, which impacts cracks. So there is a little bit of leeway dependent on, this is, they cannot consider the states to have the same exact thing. They have to have some flexibility in here. But generally speaking, after you average all together, then you come up with which ones are good or which ones are fair and which one are poor. Then you do your data interpretation. So basically, this is how they can see. They split every state into divisions. You can do that here. Some people do it as geography. Some people do it rural versus urban. Some people do it by like zones. You have zones that are cold, zones that are white. So you can do it however you want. And then you can color code the condition within every zone, again, however you want. At the end, you have to be using the same baseline for your state or for your country, right? And this is basically the end of the story. Once you color code, you have your curves, you can come up with your decisions, which basically I need to have the software in front of me to show more, but I showed you the curves. I showed you how to draw X and Y, what impacts the X, which is basically time, what impacts the Y, which is PCI or PCR, and then how you combine the network, the individual project level to make a network level, and then at the end, based on the financial restrictions, you can take your decision whether do nothing or do current preservation or wait, and maybe you will do maintenance later when it gets a little worse. Any questions? Open the floor. I'll be surprised if I don't have questions. So yesterday I told you, you guys asked me a lot of questions. You didn't ask Patrick enough. Today you hammered him with questions. Are you scared of me or what? How many questions did you get today? 10, 12? I got nothing? That's unfair.
Please, we need questions. Dr. Amin, a round of applause to Dr. Amin Aknok. Sir, they understood very well what you were teaching them. You know, now our pavement management systems, you know, they are very, very safe. And I want to believe we enjoyed his lectures and especially put into use and practice what we have been taught. Once more, let's put our hands together for him. And sir, thank you for the time. You managed the time very well. I didn't have to come on. All right, ladies. Okay. Oh, good. All right, ladies and gentlemen, while we were having the lectures, if you notice, the atmosphere changed. Who noticed anything? Who noticed what happened while we were having the lectures? You know, some movement. Was there any vibration between the bridges and things like that? Anything? Some vibrations. And we use the pavement management system to address it, right? Oh, that's good. A round of applause for yourselves. So, ladies and gentlemen, while we were having the lectures, one of our very own key stakeholder, especially as regards this training workshop we are having walked in, let us make welcome and put our hands together as we welcome the Director of Bridges and Designs, Federal Ministry of Works, Engineer Bede Obioha. Let's put our hands together for him. We'll now ask him to please come forward and then have a few tete-a-tete with us. Let him give us a goodwill message. Please, if this is how you will clap for him, we'll meet in the office, so I'll be looking at them.
Thank you. Good afternoon, distinguished ladies and gentlemen. Let me start by thanking NIHTE and IRF for putting this together. Yes, we are desirous of training our engineers to come up with pace, but I think the last lecture was too advanced. Don't worry, we'll get there. We're not there yet, but we'll get there. So learn in advance so that when we get there, you understand how to go about it. No knowledge is lost. Yes, we may not be practicing these things now, but definitely one day we'll get there. So on behalf of management of the ministry, I don't know whether it's only Federal Ministry of Works participating, because most of the faces I'm seeing are our staff. If you are from Federal Ministry of Works, raise up your hand. You don't finish now? Clap for yourself, please. Thank you very much, and the ministry is desirous to collaborate more. If you come up with programs like this that are very educative and will improve our staff, we surely key in and see how to make it work. Let me thank my engineers for marrying both the work and the training. I know I've had cause to recall some of you to come and handle some urgent assignments. You did that well and came back and fitted in again. Thank you very much, and I wish you a very good and fruitful deliberation, and we expect you back in the office on Friday. Thank you, and God bless all of you.
You people did not know that Oga just took attendance. Where are you? Please, a round of applause for him once more. Thank you very much, sir, and especially for your support for our trainings. Thank you.
I think before Engineer Abiola leaves, we will call for some group photographs with as many people as possible. But don't take that picture until I'm inside.
Ghanaian delegates, Ghanaian participants. All right, thank you very much. So, ladies and gentlemen, lunch is served. But before then, when we come back, we shall be taking development of highway materials for enhanced roadway sustainability. Please, let us go calmly to have lunch, and let us try and have it quickly and come back in 30 minutes. So we can finish on time.